Hi, and welcome to this crash course on database proxies. This is going to be mostly an introduction or overview of database proxies, what they are good for, how they work, etc. So my name is Alejandro Duarte, and I'm a software engineer. I published these 3 books about web development with Java, and I work in developer relations at MariaDB. So we're going to use these 3 things: Java, just a tiny bit. You don't even need to know Java. Actually, it's only because I need to show the connection string. I just want to show that. So it's not even Java code at all. We're going to use MariaDB, which is obviously my favorite database, and something called MaxScale. First, we're going to see what is a database proxy and the elements and the architecture and so forth. We're going to see how to scale specifically reads. And then we're going to see other use cases. And finally, we're going to see disadvantages and advantages so that you can make an informed decision on whether to use a database proxy or not. So first, what is a proxy? More general, right? A proxy, what is it? So when you have a client that needs to communicate to a server, a proxy is something that sits between these 2 guys. And it's there in a way that the client totally thinks it is actually talking to the server, and the server thinks it's actually replying to the client. So they don't know that there is a proxy in the middle handling this communication. The proxy just sends the request from the client, forwards it to the server. Then when the server kind of generates a response, then it sends that response back to the client. Now, if the proxy is on the, let's say, the local network of the client, it's usually called forward proxy. And if it's located in the local network of the server, it's called reverse proxy. These, the reverse proxies, they have the advantage that they can add functionality without having to modify the client. They can add things, for example, to increase high availability, scalability, do integrations with other systems, increase security, or put mechanisms that improve security. Now, what is a database proxy more specifically? So it's kind of the same. It's just that now we have, for example, a web server or a web application or a mobile application, desktop application, device on the edge, whatever, that it's going to communicate to a database. So a proxy, and a database proxy, sits in the middle again. We are using MaxScale here, which is a proxy, a database proxy that understands SQL or SQL. And because it understands SQL, that's the reason we call it intelligent, because it can make decisions based on that code that you send through the proxy. So it knows, for example, if SQL sentence is select, or maybe it's an update or something different. So this is an intelligent database proxy. Now, as with any other kind of proxy, it can add functionality to the system in terms of high availability, scalability, integrations, and security. And we are going to see concrete examples of all these 4 categories, all right? So let's explore some of the concepts and the architecture of a database proxy. And for that, we're going to use MaxScale as an example. So you have a client, again, it could be a web server, web application, mobile application, desktop application, whatever. And it needs to consume a database. And the database is actually a cluster. There are multiple machines there, multiple nodes, multiple instances of the database running, okay? Now, to simplify everything, we introduce a database proxy. And MaxScale has one component there called the core. And the core maintains and stores, or actually stores the cluster state, and makes it available to other components inside the database proxy. There is another component called the monitor, which monitors the database cluster, all the machines there, and updates that cluster state, so that now the proxy knows whether, like, how many servers are there, which ones are in maintenance mode maybe, or which ones just failed, and this kind of stuff is stored there inside this database proxy. Now, when the client needs to connect to the database, like a web application, it does it through a protocol, a wire protocol. It could be MariaDB, for example. There are others. We're going to see examples of that later. But let's say it's MariaDB, and the protocol has a port, a number, just like if it was a database. In other words, the client totally thinks it's talking to one database, and that's it. Has no idea what's going on, which is a desirable thing. It simplifies the perspective the application has, and hence the developer doesn't need to worry about it. Now, this request is sent to a number of filters. It could be 0 filters, no filters whatsoever. It could be 1, 2 filters, like in this example, 3, 10, whatever. And these filters modify this request through a parser. And then later they could even modify the reply, the response, when the data is flowing in the opposite direction back to the client. After the filters, this is sent to a router, which uses this cluster state that is available there through the monitor, or the core component rather, is updated by the monitor, but it's available in the core component here. To decide, this router decides where to send this request using, again, a protocol. So which node in this cluster, which machine, which actual database instance should I send this query, for example, if it's a query. Now, the gray and the green rectangles or boxes here, they are configurable parameters, kind of. They're objects that you can configure in max scale. So all those things you can adjust, you can set a bunch of things on these things. So let's see the configuration, how you configure a database proxy. In the case of max scale, you have configuration files.cnf, and for some of the things that you have to use JSON, but we are not going to go through that. Here's an example. So I have a configuration file, and pay attention to these two sections here first. So we are defining nodes 1 and 2. They are servers. It says type equals server. Address, the first one is 10.0.0.2. The port is 3306, which is the default for a MariaDB database, and the protocol is actually a MariaDB backend. So it's it seems that this is a MariaDB database living at 10.0.0.2. Same with node 2. So we're defining 2 servers. You can define more things, but this is just a quick example. You can do the same using the command line through a tool called max control. And if you look at this section over here, you see that we are creating the same nodes, node 1 and 2, and a third one with their IP addresses. But we are also creating or defining a monitor, right? We're creating the monitor. Remember the monitor from the architecture? It is the one that monitors the cluster and updates the state. We're saying we can create many of those monitors. Now we're creating one, we give it a name, and we're saying, hey, please monitor node 1, 2, and 3. Same here in this section. We're creating something called a service, which I actually didn't put in the architecture diagram. But you see that there is something that says read, write, split. You see that term there. We're going to see that in action, or an example of what it means. We're configuring this to do read-write splitting. We're going to see it later. Through servers, node 1, 2, and 3. So a service makes a cluster, in this case, 3 nodes, look like if it was only one to an application. That was the command line. Now you have also a REST service. That's pretty cool. So I have some JSON object here, and it seems I'm just adding now node 4 with the IP address 10.0.0.1 and the port 3306 also. Then we invoke that. Here it seems that we are using curl to invoke the REST service from the command line, but you can invoke these from your application. You can develop application and call a REST service just like you would do with many other things, right? So that means that you can maybe automate things or make things available for configuration. And there's also, it's super cool, a web graphical user interface, right? So you go to the browser, you log into this GUI, and then you have a dashboard with all the servers. Now, here I have MariaDB 1, 2, and 3 in that dashboard, which is like node 1, 2, 3. So it's just different, but you get the idea, right? It's just the servers, the actual servers. And we have the monitor, we have services, listeners, filters, everything is there. You can see sessions, connections, the load, a bunch of things. You can also create, it's not only for visualization, you can configure max scale. So you can create a server, and you can see that you can create the other things too, services, monitor, listener, filter. just like we did in the command line, then in the configuration file command line REST service, you can do it now with you can do it also with the GUI, just clicking things here and filling the form. So it could be even, could be less error prone for certain things, up to you. You can visualize the cluster, the topology. So you see, okay, we have 2 listeners there, so I can connect to this cluster through 2 different endpoints, 2 different ports, it seems. We'll see later what is that all about. There's a service, so the 3 MariaDB servers look like only one. There is a monitor down there taking care of updating the state of the cluster. So you can visualize this. It's very useful. But you can also run SQL using max scale. It's like a SQL client that it's available right there for you, and you can connect to a particular specific server in the topology, one instance, or you can do it through the listener, right? So that you test the whole thing, for example. And there is a functionality to see all the tables, schemas, and filter data and order, etc. Let's have a look at how to scale reads, specifically reads with a database proxy. And for that, we're going to use a technique called read-write splitting. So let's say you have 2 instances of a database. Now you activate replication here. You configure and enable MariaDB replication. That means that when I write data in the primary node, it gets automatically and almost instantly replicated in the other node, in the replica. So you have data in both automatically. If you want to learn how to configure this thing or the details on how it works, then there is a video on the official MariaDB YouTube channel, Scaling Databases Data Replication Tutorial, that I can recommend, where I explain exactly how to configure all this stuff. Once you have that, your application, for example, it's a web application, can send the writes to the primary and the reads to the replica. So now you have, now the primary doesn't need to, run queries, just updates and inserts. You can scale up the horizontally, actually, you can scale horizontally the reads by adding more replicas, okay? And then you do load balancing between these 2 replicas. So you can handle more and more reads. And you can do the opposite. You can remove a replica when you don't need it to save costs, for example. Now I put this arrow here in red for a reason, because when you add a replica or remove a replica, you need to reconfigure the web application. Or maybe it could be even worse. You will have to maybe implement the load balancing. You might have to, or if you don't want to, if you want some kind of dynamic configuration there, then you will have to implement that in the web application. That's code that you have to maintain. Now, in the case of Java, you can just use a connection string that does the load balancing for you. You just say their replication. There's just a tiny bit of Java there. It's a string that defines the connection to the database. And you can specify the IP addresses, for example, of the primary, the replica 1, replica 2, and the driver, the DBC driver is called, like the connector for Java. It does it automatically. It does the load balancing automatically for you. So that's cool. However, if you want to add one more replica, you will have to modify this string, which means that maybe it requires a restart of the application. So it's downtime, right? So that could be a problem unless you implement something, but then you have to implement that something. If you replace that with a database proxy that automatically does this read-write splitting for you, you configure these things there and connect the web application instead of to the primary and the replica. You just connect to one endpoint, the database proxy. Then you need to worry about changes. You can add a new replica or remove it. And here I didn't put it red because this is, you can use for example, the graphical user interface or the command line or REST service to reconfigure max scale at runtime. Doesn't need to restart anything. Just define the new replica, done. The web application continues to use just one single point, one single connection string in the case of Java, one connection object in case of other languages. No need to worry about how many replicas are there or if one disappeared or one appeared. None of that. The web application doesn't need to change. It just notices now that for some reason it can perform reads faster, for example. So that's what's happening here. Also, it's resilient, right? A bit more resilient, because if a replica fails, I can still read the data. So it's this kind of stuff that you gain here with this topology. Now, talking about topology, all these is the topology, current topology of the database, could be changed. It is isolated. There is topology isolation, and we can change it by with something like this. Here I have, for example, 3 availability zones, or regions even, or maybe clusters, whatever it is. Maybe some of them have even columnar store through MariaDB column store to make analytics faster. So these kind of queries that are like, that work with a whole column to calculate an aggregate function there, to calculate, for example, an average or count. Now it's in column storm, so those are going to be faster. And I didn't need to change the web application at all. It's just faster because I have now column store there, some nodes. And because I was using MaxScale, I didn't need to change the web application. That's pretty cool, right? So let's go into more details on like what kind of things could happen here. For example, in terms of read-write splitting that we just saw. Let's say this green server here is a primary node, okay? Now, this primary node could fail, right? Something could happen. Maybe, something crashed in the machine, the operating system failed, an update that didn't went through correctly, or somebody even disconnected the wrong cable in the cluster, which I have to confess, I did it once many years ago. I disconnected the wrong cable in a very small cluster in a small company. Fortunately, it wasn't production, it was more of a testing, but it kind of, it was a problem, as you can imagine, because nobody was able to run some tests. So we make mistakes and things could fail. So what happens here? This primary node failed. MaxScale can pick another one and promote it as the new primary. So the application can continue to write data in this database and all these topology, no problem. Sure, maybe there is reduced capacity, but if it was planned very carefully, it's not even noticeable. The web application doesn't notice. The user doesn't notice any decrease in the performance. That's the whole point of having all this replication, or part of the point at least. Now, the thing is working as before, except maybe, like I said, reduce capacity. At some point, that failing node is going to be back. It's going to be recovered, restarted, or you plug the cable that I disconnected accidentally back in the slot, and now it's available. MaxScale detects this automatically and configures the previously primary server as a new replica, and all of a sudden you have the same capacity, the same topology working as before automatically. You don't need to worry about it. So this is more or less how you do read-write splitting, and how MaxScale allows you to even use more complex topologies, completely isolated, and they evolve without affecting web applications or applications in general. Now let's see some other use cases for database proxies, because there are many. First, let's start with scalability and performance too. We already saw read-write splitting. We saw load balancing. The database proxy can do these two automatically for you. There's something called causal read. So when you write data, it goes to, say, the primary, and it could take an instant, right, to get replicated in the other node. So maybe you run an insert, and then you at the same time read, almost at the same time, but after the write, you read from the replica, but the replication process it's not done yet for that row. So you might get wrong results, right? Causal reads, you enable this. There are several options, mechanisms, or ways for this to be configured that I'm pretty sure that you will find the one that matches you. So you compromise basically a bit on on the delay of the query. But there are several options there, so it's very easy to find the one that fits perfectly your use case, your application. Caching. You can cache the results. So you run your application runs a query and it's running it all the time and data doesn't change, for example. That's a good candidate for caching that query. So we cache the results. We just configure it there. We create a filter. The module is called cache. You can configure a bunch of things there. Done. It doesn't need to go to the actual database nodes to return the result. So it gets faster. On the high availability front, we have automatic failover that we saw it, right? When a primary node fails, another one gets promoted as a new primary. That's configured somewhere in the GUI here. Just say auto failover, true, done. Then MariaDB MaxScale can do automatic failover for you. And the other one is auto rejoin. So when the failing, the server, the node that failed is available again, gets detected, and it rejoins automatically and it's configured accordingly, right? That's also something you can configure there just by setting this flag to true. Transaction replay, this is closely related. So for example, when the primary failed in the previous example, it would return an error that you have to catch in your code. You have to handle that error. Maybe there is a try-catch block if you're using one of those languages with this construct. You will have to handle the error somehow and then retry, like put a loop there, like 5 times, for example, and try. If after 5, then okay, we show the error. There's nothing we can do. But maybe, at some point, MaxScale is able to reconfigure everything, and now you can run the transaction somewhere else, and it doesn't fail, right? So the application doesn't need to handle this. You can remove that code if you have it, or you can just not waste time coding that part, which is pretty amazing. This is very, very, very useful for developers, I would say. On the integrations part, I wanted to show you this. So change data capture, which is kind of sending the changes in database, data and schema somewhere else. And it's usually, the industry standard almost is Kafka. You send it to Kafka, right? To a queue. Usually, like I said, Kafka. So this means exporting to Kafka. The events in the database, you export those to Kafka. And then from there, you can do whatever you want to do. Whatever you can do with Kafka, you can do after that. Really powerful feature, automatically from the database. No need to implement anything or add dependencies or anything extra if you already have the proxy, obviously. And the opposite, you can ingest data. So data ingestion through Kafka. So you kind of receive these changes and do whatever you want to do. Like, for example, you can write to column store for fast analytics, this kind of stuff. So it's importing, exporting to Kafka. You can do it from MariaDB MaxScale. The NoSQL protocol, it's pretty cool too. So here in the screenshot here, I'm creating a new listener. Remember, the listener was what the application used kind of to connect to the database, and it has a port and all these, and a protocol. Well, there are several protocols. So it's Kafka, and then you have MariaDB, but you also have NoSQL. In this case, MongoDB. That means that if you have this scenario here, you have a web application. Yeah, I'm showing here like if it's Java, but it could be anything. And you implement that application you connect the application to MongoDB. Then you add the dependency there. In the case of Java, that's not JDBC. That'll be another extra library there. And you probably use MongoDB query language instead of SQL or SQL. You can send those queries, the connections, to MaxScale because MaxScale is an intelligent proxy. It also understands MongoDB query language, MQL, and it can translate that to SQL and store the data in a MariaDB database or cluster. So you have this data in a relational database now. So from NoSQL to SQL, you don't need to modify the application. The application totally thinks it's talking to a MongoDB database. It doesn't know. Then you can use that data. It's stored, by the way, in the MariaDB database. This is stored as a JSON document, right? And there are JSON functions, which you can use to manipulate this data or transform it in a to like a table kind of thing, and then do joins. So you can select from what got inserted from like in a MongoDB kind of way, a JSON document, join that data with relational data that you have maybe from other applications. So that's pretty powerful. And that's the NoSQL protocol. Now, on the security front, we have things such as the query log. So you can query you can log all the queries automatically there. You can define a query limit. This is called throttle filter, right? So it's a filter. And you say how many queries can somebody run in certain period of time to avoid certain kind of security attacks, right? For example, denial of service and this kind of stuff. Same with result limit. Now it's just you are limiting the number of rows that get returned to the client. Again, could be for increasing security. So when you do a select and you forget to put some kind of filter where clause there, then you don't accidentally return 1 billion rows or something like that. It's not what you want. Data masking. This is something that, well, you define there a masking. You define a JSON object with an expression that it's kind of a regular expression to transform the data, and then that gets returned to the client. And that's very explained with a screenshot of an actual application, an example application that I implemented. It's a CRUD, so it's create, read, update, and delete. It's running on the browser, and it's connecting to MariaDB. It's just information about people, right? So I have four guys here, and this is coming from this SQL query, select all from a person, which, by the way, I didn't put a where there. So if I have 1 billion rows, it's going to return 1 billion rows. But since I was using MaxScale, then I could add this result limit, and that's fine. It's not going to impact the database and potentially other applications that are using database. Anyway, so this is not the important thing, or what I wanted to talk about here in this screenshot is this column here, credit card number, which is very sensitive information. Applications shouldn't be able to see those numbers. Well, I created a masking rule somewhere there in the MaxScale that changes all the characters except the last 4 digits of the credit card number with a star, right? And I didn't implement any logic here to show stars there. That's what I got from select all from person, really. No need to implement this thing. It was automatic, so it's pretty cool. So you cannot accidentally show credit card numbers anywhere. That's data masking with MaxScale. Now, everything sounded perfect with database proxies, but there are disadvantages. There's disadvantages always, right? It cannot be that it just adds good things and there are no disadvantages. So let's explore some of those. So you can decide where database proxy is the right tool for you or not. First, they add elements to the infrastructure. That's pretty obvious, but I'm saying this because these elements need maintenance. You need to maintain those things. Now, if you're using cloud service like maybe MariaDB SkySQL, which, by the way, it uses MaxScale, so you have all this stuff there, then you don't need to be worried about maintaining that new element. At least not in the same sense as if you were hosting it by yourself on premise. They obviously require configuration. So that means that you need to be able to adjust everything and learn the parameters and the options that are available to you. So when you are deciding for a database proxy, always check what are the configuration options. Does it have a graphical user interface? Does it have a REST service so I can maybe do some integrations, automate things? Does it have a command line tool that I can maybe use for scripting or on scripts? This kind of stuff. So they do require configuration, obviously. That's the case anyway with any other software that you add to your to your system. As well as this, it can increment costs, obviously, right? Same with other pieces of software. So this could be licenses or cloud usage. In the case of MariaDB Max Scale, it is open source, and it is you can use it for free up to a certain number of nodes that you should check the license before using Max Scale. But there is kind of a limit there for sure. So there's another advantage. Now you have to contrast this with the advantages. So is this a fair price for these things? So database proxies basically abstract away database infrastructure, which is desirable because it all looks like a standalone database instance to developers. Remember, for example, in the case of read-write splitting, it looked like if it was just one single endpoint. It was actually one single endpoint, but it was 3 nodes. And it could be, later I showed you, even multi-region, multi-availability zone kind of setup and topology. Database administrators can add or remove replicas and cluster nodes when needed, right? Without interfering with applications. No need for developers to implement things like load balancing or data masking. We saw it with the credit card numbers, load balancing with read-write splitting. But other things like the MongoDB listeners, that you store data from an application that was developed for MongoDB. Now you can store it in MariaDB instead, and then join that data with other relational data and make it available to other applications through the same database. DBAs can make changes without interrupting applications. So they can add a new node, they can remove when it's not needed to save costs. They can do these things and the application just continues to run, doesn't need to be restarted, anything. Database proxies also hide and manage failures automatically, right? We saw that when a primary node failed, another one, a replica, was promoted as the new primary automatically. No need for manual intervention at all. There is no need for developers to create new connections or retry transactions. So when this thing kind of happens, then you don't need to have some logic in the code that detects that handles the error and then tries 3, 4, 5 times. You can remove that code. No need for DBAs to perform manual failover after being altered, so they can use their time better instead of just reconfiguring everything again and promoting, do all the work of promoting one node to a new primary, this kind of stuff. The database proxy can do it for you automatically, and you can save that time. DBA costs on that time, right? That's costs also. They can investigate what happened, focus on that, or they can, advise on better strategies and modifications and for the database topology and the kind of thing that it's more usable for your business. Now, I'm going to leave you with this screenshot of this website. It's a blog by Nicolas Tobias, who is a DevOps engineer. It is in Spanish, but I translated it for you to English. He is asking, what is MaxScale? Well, in one word, it is a database proxy that, since I discovered last year, I haven't stopped using. So I invite you to try it out. Go to this GitHub repository. There are detailed instructions, steps on how to set up these using Docker. So it's very simple, and you can remove it after you've played with it if you want. You can test these things. You can connect your own application maybe to MariaDB MaxScale, a database proxy that it's intelligent and starts SQL, Kafka, and understands also NoSQL. It's pretty impressive. Try it out. It could be the thing that you cannot stop using. So thank you. And feel free to contact me on Twitter, GitHub, or even email if you want. I'm happy to talk about anything MariaDB, software development, or really any topic that you want to talk about. I'm happy to hear from you. Thank you.